Hello everyone, welcome back. In this video, we are going to continue our conversation about analyzing domain and range for the radical function. In the previous video, we briefly discussed how we analyze the domain and range for this simple function here, always call this parent function square root of x, and we know it has a very special feature. Feature is starts, or you can see end at one point and goes forever for one direction. So in this video, we are going to look at more examples here. Let's check the first one. So when we analyze this kind of a domain or range, the very first thing we always track where the graph starts, or we say where the graph ends. As you can see here, the -4, 0 is our starting point. So we will use this as a point to analyze the two directions. For the x, horizontally, because this is about domain, about the x, and for the range, which is vertically how the graph changes for the y, okay? So let's check. For the x, as you can see, the graph is actually to the right direction because overall the graph is to the right. So that's why the domain is x greater than or equal to, since the value x value here is starting with -4, so it's greater than or equal to -4. Or you can also write in this notation. This means x start with -4 and this bracket here meaning included, meaning -4 can be reachable, so -4 to infinity. And for the range, let's check vertically. So vertically, you can see the graph since it's slowly increasing, so that's why vertically it's also going up. But some students might say, oh, for the range, does that mean y is also greater than or equal to -4? No. For the y, you have to check the vertically for the y value, which is here is 0. And also you can check the coordinate of the starting point, which is also 0. So it's y greater than or equal to 0. Or we can put a 0 to infinity. Okay, that's just a different way to notate this final answer domain or range, but it's actually meaning the same thing. Next, we still look at the graph slowly increasing. So we can see they both probably going to the positive direction. However, the starting point, this is a little bit different. We read the x first, which is 1, and then we read the y, which is 2. This is the starting point, right? And horizontally, again, is going to the right. So we are going to put the domain as, again, this is the way we put it, meaning this is about x greater than or equal to 1. Also, if you're not sure, you can always pause the video or rewatch the video, or even just, totally pause it to see if you have the same answer with me. Or I can write the answer as 1 to infinity. For the range, vertically it goes up. So that's why, as you can see, the range is actually starting with, what's the point here? Is actually 2, right? So it's y greater than or equal to 2. Or I can write as 2 to infinity. Okay? Next, some student might say, is that possible the radical function is always going to the positive way? No. If we flip the function or whatever the way, deal with different kind of function, we might see something different like this. Again, we always check the starting point. Some students might confuse about, hey, I have 2 points here, like bolded. Should I move from this one or this one? Remember, you need to go back to track all the positive values. So you have to track where do they totally start, or we say where do they totally end. So that's why we need to focus on this one. And let's write down coordinates, which is 1, -2. For the x is 1, for the y value is -2. Again, we analyzing two directions. For the x, as you can see, this time is actually going to the left. So it's going to smaller and smaller because it's going to the negative direction. So for the domain, is still about x, but this time it's getting smaller. So it's x less than or equal to 1 because this is a part way for the x, okay? This time, since it's less than, so that's why y is on the right side, and then this is going to be negative infinity 1, okay? This is how do we write this way. It's like the location for the number line. And for the range, is about y, but still, if you look at the graph, it's still slowly increasing, so that's why y is still going up. So y is greater than or equal to, as you can see, the y here is -2, so that's why it's -2 here. or I can write it as -2 to infinity because it's getting bigger and bigger. Okay, that's all the example I want to share with you. Thank you so much for watching, and I hope this video is helpful. And see you soon, everyone. Take care.